Have you ever stopped to think about how strange and fascinating snakes truly are? Creatures that glide without legs, see the world in ways no other animal can, smell with their tongues, and some are even capable of swallowing whole prey larger than their own heads. Today you're going to discover the most incredible curiosities about snakes, from their prehistoric origins to the secret mechanisms they use to survive, hunt, hide, and even see heat. Get ready, because after this video, you will never look at a snake the same way again. Have you ever stopped to think about how strange and fascinating snakes truly are? Creatures that glide without legs, see the world in ways no other animal can, smell with their tongues, and some are even capable of swallowing whole prey larger than their own heads. Today, you're going to discover the most incredible curiosities about snakes, from their prehistoric origins to the secret mechanisms they use to survive, hunt, hide, and even see heat. Get ready, because after this video, you will never look at a snake the same way again. Cut to title: The Origin of Snakes. Where did they come from? Many people imagine snakes were always the way they are today. Long, legless, slithering creatures. But the truth is that snakes once had legs for millions of years. Yes, snakes with 4 limbs actually existed, and this isn't a theory. It's paleontological fact. The lost ancestor. Snakes with legs. Around 100 million years ago, during the Cretaceous period, some lizards began gradually losing their limbs, likely because they lived in underground burrows. Life below ground favors elongated bodies capable of sliding into tight spaces. Over time, legs became a disadvantage. Fossils of species like Tetrapodopus, a snake with 4 small limbs, have been found. These limbs were no longer used for walking. They may have been used to grasp prey or assist during mating. In other words, snakes are modified lizards. Losing their legs was not a deformity. It was an advantage. The loss of limbs wasn't a genetic defect. It was an evolutionary advantage that allowed them to enter burrows to hunt mammals, made ambush hunting easier, made their bodies more aerodynamic for slithering, improved camouflage. This anatomical change was so effective that snakes spread across the entire planet, except Antarctica, Iceland, and a few isolated islands. The strangest body in nature. What does a snake's anatomy look like? If you could see the inside of a snake, you would probably be amazed. Everything inside them is different from what we find in other animals. A thread-like body. A snake's body is a narrow corridor, so everything inside must be thin, elongated, adapted to a tubular space. That's why most organs are arranged in a line, not side by side. A walking heart. Yes, this is real. A snake's heart is mobile. It's attached by loose tissues that allow it to move forward and backward inside the body. Why? Because when a snake swallows large prey, the food can push organs around. If the heart were fixed like ours, it could be crushed. Mobility allows it to shift and keep functioning. Asymmetrical lungs. Snakes typically have one fully functional, elongated lung and a second lung that is reduced or absent. This frees up space for muscles and digestive organs. A flexible spine with over 300 vertebrae. Humans have around 33 vertebrae, but snakes can have 200 to 400. Each vertebra has ribs, giving snakes the strength and flexibility to slither, climb trees, swim, and even scale rough walls. How do snakes move without legs? It sounds simple. They crawl. But the movement is far more complex. There are 4 main types of locomotion. 1. Serpentine movement, the classic. This is the S-shaped motion everyone knows. The snake pushes its body against the ground, creates anchor points, and moves forward like a wave. It's the primary mode for terrestrial and aquatic snakes. 2. Concertina movement, the accordion style used in tight places or when climbing trees. The snake anchors the rear part of its body, extends the front, then pulls the rest forward like an accordion. Slow, but powerful. 3. Rectilinear movement, when the snake walks forward, common in large pythons and boas. They use belly muscles that grip the ground and push the body straight ahead with no side-to-side motion. It looks like they're gliding on a conveyor belt. 4. Sidewinding locomotion. Desert snakes, like the sidewinder rattlesnake, use this method to move across hot sand. They touch the ground at only 2 points, reducing contact with the scorching surface. The result, one of the fastest and most efficient forms of movement in nature. The most advanced sensory system among reptiles. Snakes have senses so unusual they seem alien. Let's break them down. Vision. Some see poorly, others see heat. People often say all snakes have poor vision. That's only half true. Some do have poor eyesight, but others see exceptionally well. The queens of thermal vision vipers, pythons, and some boas have special organs called loreal pits. These pits function like a biological thermal camera. They detect heat, infrared radiation, the body temperature of mammals from several meters away. To a snake, a mouse is literally a walking warm light in the dark. They combine thermal vision with regular vision to create a 3D heat map of their prey. Smell. Snakes smell with their tongues. One of the most iconic features of snakes is the forked tongue. Why is it split? Because the tongue collects chemical particles from the air and delivers them to a special organ called the Jacobson's organ, located on the roof of the mouth. This allows snakes to track prey, detect mating pheromones, identify the trail left by another animal, sense predators. The forked tongue creates a chemical GPS. Each tip gathers information from a different direction. Stronger scent on the right, prey is to the right. Stronger scent on the left, prey is to the left. It's more accurate than many artificial sensors. Hearing. Snakes have no ears, but they do hear. Snakes have no external ears, but they have internal bones that detect vibrations from the ground. They don't hear airborne sounds like we do, but they detect footsteps, impacts, and ground movement with extreme precision. For a snake, a walking animal isn't a sound. It's a vibration traveling through the earth. Touch and special pressure sensors. A snake's skin is packed with sensory receptors. Many species can feel tiny changes in air movement, detect nearby objects without seeing them, adjust muscle tension to climb surfaces. Snake skin, a machine of camouflage and growth. Snakes shed their skin throughout their entire lives. This process is called ecdysis. Why do they shed skin? 2. Grow. Renew damaged outer layers, remove parasites, maintain color and camouflage. During shedding, the snake becomes blind. A few days before shedding, the eyes turn bluish and cloudy. This happens because there is a clear scale that covers the eye. It detaches along with the old skin, creating a film that blocks vision. During this time, snakes become more irritable and reclusive. They're vulnerable. Snake skin is never slimy. Snakes are not slimy. Their skin is dry and smooth. The myth of slimy reptiles comes from amphibians like frogs and salamanders. An incredible fact, snakes don't have eyelids. They cannot blink. Instead of eyelids, they have an ocular scale, a transparent shield covering the eye. This means a snake sleeps with its eyes open, always appears to be staring, cannot close or lubricate its eye voluntarily. Breathing and feeding, how snakes survive, swallowing giant prey. If a human swallowed something huge, it would crush their windpipe. Snakes, however, have a trick. Their trachea can move forward. During feeding, the snake extends its windpipe outward like a snorkel, allowing it to breathe while swallowing its prey. That's why they can swallow large animals without suffocating. Neck, chest, hips. Snakes have no clear body regions. Although they appear to have body segments like most vertebrates, snakes are essentially a head, followed by a long trunk and a short tail. There's no defined neck or hip region. Almost the entire length of the snake is trunk, with organs arranged sequentially. The evolution of fangs. A snake's mouth is a biological miracle. A snake's mouth is one of the most incredible structures in nature. Jaws that disassemble, but don't truly dislocate. There's a myth that snakes dislocate their jaws. They don't. What actually happens is, the left and right jaws are not fused at the front. Each side can move independently. Extremely elastic ligaments allow the mouth to open extraordinarily wide. This lets them swallow prey much larger than the diameter of their heads. Recurved teeth. Their teeth are sharp, angled backward, impossible for prey to pull away from. The more prey struggles, the deeper the teeth sink. The secret of ingestion. How snakes swallow. When a snake captures prey, it doesn't chew. It swallows. The body muscles perform an amazing task. The prey is pushed down by powerful contractions. Stomach acids are extremely strong. Bones, hair, and feathers are almost completely digested. Some species digest up to 95% of everything they swallow. If you enjoyed our content, subscribe to the channel and turn on notifications. Stay tuned for our next video.